So you're close to like.
All right.
Pretty close.
Hey, how's it going?
It's like an hour south of that. Oh, okay. Fun school, but yeah, it wasn't that great.
Yeah, right. In the day, especially this.
We gotta go for the presentation.
Welcome. Come in and find a seat. Anywhere? Anywhere at all?
Anywhere except in the middle. Anywhere else.
Oh. Yes. I could double check. Yeah. It's looking good. Professor Weiss. Hello, welcome. Come in. Find a seat.
While you guys are waiting, you can check out our website.
Yes. Scan the QR code.
Yes.
Anywhere that's not in the middle.
There's a QR code once you
What? I think we'll just do it after the presentation. We're probably just here to get her around. Before we go. Should have a slide. Oh, yeah.
Well, that might be the website, but just the URLs are there.
Yeah, I checked it before.
I think this is like the biggest or the most build up we've almost had. Like it's been a while since we had it.
Feels like there's like one or two left.
Yeah.
Basically, how's that ID now?
My sister TA wanted.
I saw it.
You saw it.
I see you wearing that all the time.
Are you kidding?
I had a lab
Oh,
in the
hallway.
And then his brother Justin is TAing. with the
Oh yeah, my
same
job is
class.
TA cybersecurity class.
Yeah.
Hello, welcome. Come in.
Yeah.
Is he the one with Professor Chen, the one with?
Just saying. Yeah. Yeah. They keep telling me that I should get this. I'm a founder. Hey, 6:30. Hello. Hi. Anywhere except here. So any other. It's gonna go up. Okay. Over there. Over there.
Oh, clean website.
All right. Great.
I don't even know why you went back.
All right, we're about to start. We're just waiting for Professor Weiss, and in the meantime, feel free to go ahead and scan the link. Visit our website,
Anywhere
umlcloudcomputing.org.
but the middle, because we have to stand there for the presentation.
Yeah, so you can go over there, or go over there, go back there. Yeah. We can probably move the seats from there over here too. Doesn't go.
Probably make it easier to walk around.
Yeah. Yeah, maybe at the end we should have like a big photo like where everyone waves at the camera, something like that. Space to walk. Yeah. So I guess after we're done with the presentation, I'll grab my own and then we'll do a whole picture with everyone waving at the camera. Find a seat anywhere. give Professor Weiss another 5 minutes or so. And then oh, hi. Hi, Professor Weiss. All right. Okay. Wow. All right. I think that
Turnout here,
we
awesome.
got a great turnout today. Yeah. All right. Welcome. Come in, find a seat anywhere you can in the back, or in the audience chair. Should be another seat.
It's all the post of the same.
I don't know if I was in your computing class.
Sure, yeah, sure.
No, just could just say hi.
Oh, okay, hi, how are you?
All right, so the way it's going to work, I'm just going to introduce everyone. I'm then going to hand it off to Alvin, and then after Alvin, just let your questions.
All right.
All right. All right, so welcome everyone. Welcome to the Cloud Computing Club. I'm so glad that you're here today to learn more about who we are, what we do, etc. A little bit about, well, if you haven't already, scan the QR code link to get a link to our website. Our website has almost everything. It's a very great resource. We put our tutorials up there. We put our all our important links up there. So really good to know UML.cloudcomputing.org. It's a very good resource that we built over the summer. So let's see. All right. So introduction to the Cloud Computing Club. First, a little bit about who we are. So my name is Martin, and I'm actually a former student. I just graduated, and I was me along with Matt and a few others founded the Cloud Computing Club about a year or two ago, a year and a half ago. And so since then, we've really grown and we've expanded. Our current keyboard right here. So we have Professor Johannes Weiss as our club advisor. We have Alvin as our current president. We have Nick as our vice president. We have Christopher as our secretary, and we have Preet as our treasurer. So give a warm welcome to our e-board because they work a lot. They really do a lot. So, yeah, we really appreciate their effort. Okay. I forget it. This was okay. Yeah, if you see if you can find the seat. I know it's getting kind of crowded. We have another chair. Yes, I know, right? Yes. Great. Okay. Yeah, so a little bit about the club and what we do. So we raise awareness and interest in cloud computing among students. And a lot of you may be wondering, what is cloud computing? Don't worry, we're going to get into that. But we want to provide a platform for students to learn and experiment with cloud-related cloud computing technologies. You may have heard of AWS. What does that stand for? Amazon Web Services. You may not really hear about it a lot, but AWS powers a lot of the internet. Netflix, other kinds of websites that, like Netflix, are completely run on AWS. So very good to know. Very high-profile websites. So the point of this club is really to build a community of students who are interested in building and creating code and working together, solving problems together. We want to provide that space for you because we want to give you the tools that you can later use in industry when you graduate and you'll be ahead of everyone else. So yeah, and in addition to that, we organize a bunch of events for speaker events. We have guest speakers, we have people from industry who come in to talk about their experiences, and we also do hands-on activities to really build yourself up. So before we get any further, let's do a quick icebreaker. So let's go around the room. Let's state our name, our major, and what interests you about cloud computing. If you don't have an answer to that, you can just say, I'm here just to learn about cloud computing or something like that. So I know this is going to be a little chaotic, but let's go ahead and I guess start from let's start from this side of the room and work our way around. We'll start from this row and then we'll do this row, then do this row, and then come back and do this row. All right, does that sound good? All right, so let's go ahead and do that. So name, major, and what did you see by cloud computing? All right, great.
My name is Adam, also CS major, senior. Kind of here just to learn more about it and be able to like expand my skill set.
Great, great. Yeah.
My name is Omar Ali. I'm computer science as well. I'm a junior right now, and I just want to be here, to learn more, expand my knowledge in like computer science major. Thanks to my friend CJ right here.
Nice.
One more here.
And CJ, you don't have to go, or if you want to, you still can. Actually, yeah, you can go
Yeah,
ahead.
so I'm CJ. I'm the secretary for the club, computer science major, and I'm a junior. What interests me about cloud computing is being able to build scalable systems really quickly across numerous devices that span the entire world. So,
My name is Nick Botari. I'm a sophomore. I'm the vice president. I'm also Steve. Is there anyone in this room that's not?
Meeting gonna happen today or what?
Let's see. I think that's coming from.
there's also people
Is
joining.
it on mute? Okay, sorry. You wanna unmute it?
Oh, yeah.
Sorry.
Is there anyone that's not computer science? Or what do you guys?
We're also on.
Anyway, cloud computing interests me just generally. I find it very fascinating that all the stuff can be done over the internet. So yeah.
Great. Sorry, just gonna interrupt you real quick. Sorry for the people on Discord. We forgot to unmute ourselves, but yeah, right now we're just.
Put on the screen share also.
Yeah. Is the screen share on?
Oh, the screen share is not
It's
on.
not. Okay. Okay. I'm gonna go ahead and do that. Yeah. We have you can attend hybridly, and we're still working on our hybrid setup.
I did not.
Okay. Yeah. I'll let you go ahead and do that. Let's continue on. So next person.
Hi everyone, I'm Jonathan. I'm a junior computer science major, and I guess what interested me in cloud computing was I'm actually taking Johannes Lucy's
Nice.
cloud computing class.
Great.
He's great so
Good choice.
far. But yeah, I guess cloud computing is really cool. I can access a lot of computer resources that you wouldn't otherwise wouldn't be able to.
Great. Yeah. Definitely. All right.
Hi everyone, I'm Preet. I'm the treasurer for the club. I'm a junior, also a computer science major. What primarily interests me in cloud computing is the fact that you don't have to worry about a lot of stuff, that you can focus on what you want to build. And I like to build a lot of things, so I think the cloud is really powerful to be able to put your creative vision out.
And then Rohan.
Hi everyone, my name is Rohan Malou. I'm a CS major and a senior. I'm also the president of the school's Association for Computing Machinery. That meeting is on Wednesday, I believe. But anyway, what interests me about cloud computing is how it allows you to set up infrastructure so easily without having to buy all these different services, and I look forward to getting more involved in this club.
Great. Amazing. And Alvin, I guess you're kind of on this side, so you'll go first, and then.
Alright, so my name is Alvin. I'm a computer science major. I'm the president of the Cloud Computing Club. I'm a junior, and what interests me the most about cloud computing is being able to launch resources really quickly just with code.
Nice. Nice. All right. We'll do the person right behind you.
Hello everyone, my name is Viraj. I'm a senior and my major is computer science. I don't know much about cloud computing and that's why I'm here.
Great. Yeah. Right.
Hi, my name is Shruti. I'm also a senior. I'm just excited to learn more and try to build things.
Great. Yeah. And next.
My name is I'm a junior. I just want to learn more about cloud computing.
Yeah. Right.
I'm Hazel. I'm a freshman, CS major. I'm still a beginner, so I don't know much about cloud computing either. And again, I just want to expand my knowledge on it.
Oh, yeah, sure. Great. Yes. Next person.
I'm Christine. I'm a CS major and freshman, and I just generally want to learn more about cloud computing.
All right. Great. And yeah, next person. And if you can be a little bit louder, that'd be helpful for the people all the way over here.
I'm Kristen. I'm a computer science major, and I'm also just generally a student of arts.
Great.
I'm Pratham. I'm also a freshman computer science major. I'm just here to learn more about cloud computing and sync.
All right, great. And I guess we'll do this roadmap. Professor Weiss, if you don't like to go, you
Sure,
don't have
sure,
to, but
man.
if you'd like to.
Yeah, my name is Johannes Weiss. I'm CS faculty, and yeah, I mean, it's interesting question because I thought about everything really, and right now I'm mostly interested where the boundary is, right? I mean, where does it grow, right? It's such it's just a big technology. Just there's so many means so many different things, and there's so many different things. And I'm really interested to figure out where does it end? Where does it ever end?
Wow. Yeah. Wow. All right, great.
Hello, my name is Adnai. I'm an electrical engineering major. I'm a junior, and yeah, I just wanted to learn more about cloud computing.
Great. Yeah. All right. Nice. And next.
Awesome. Yeah, hi everyone. My name's Jack. Very excited to be here. I am a computer science major with a concentration in cyber. I'm theoretically a sophomore. It's my first semester here, though as a transfer. And cloud computing is awesome. I'm very excited to learn more about it and its infrastructure. It's basically the future. So yeah, very excited to learn more and network with everyone.
Great. And Ben?
Hi, I'm Ben, and I'm a CS major, currently a senior, I believe. I'm just kind of interested in seeing how cloud computing can be used to expand systems dynamically and stuff like that.
Yeah. And Ben was actually a former e-board member as well, so he was involved with Cloud Computing Club.
Yeah, I stepped back because I didn't have time, but I should have time this semester, so let's go.
Great. So
I'm Sandor. I'm a CS major and a freshman, and I'm here because I want to learn more about
great. All right. Now we'll do this row, and I think what we'll do is we'll start from you all the way to the back and come back. So,
My name is Theodore. Computer science major here. I'm a junior. And my interest is kind of like how AWS has like a machine learning model and making it it's easy to like trade models.
Great. Yeah. Bedrock and other same thing. Yep. Great. Next.
I'm Logan, I'm a junior, and computer science, and what interests me the most is that I don't know much about it, so I'm excited to learn.
Great. Yeah.
Hi, my name's Ron. I'm a junior computer science major, and I just want to learn more about it. I got a chance to do one of the foundational certs, and I was like, wow, this is really cool. I want to learn a little bit more, so that's why I'm here.
Oh, nice. So you actually did the AWS certs. Great.
Just the lowest one, but yeah.
Well, that's a great start. It's a great start. Yeah, great. Okay.
Hi everyone, my name is Connor. I'm a computer science major, sophomore, and what interests me is serverless architecture and like how quickly you can scale with it.
Okay, yeah, great. Amazing.
Cool. My name is Kilby. I'm also a CS major, freshman too, and I'm just here to like learn and have fun.
Yeah, great.
I'm Will. I'm a comp sci major. I'm a freshman, and I'm excited to learn more about comp sci and cloud computing as well.
Great. And I think we'll start from this end and go all the way down. And then that'll be it. And then we'll get to the people. Great.
Hi, my name is Sam. I'm a junior, and what interests me the most about cloud computing is that I kind of work in it. So I have the on-premise part, like like private cloud, but I never really done the public cloud route. So I want to be able to do both and like just like understand more.
Great. Yeah.
Hi, I'm Roshan. I'm a sophomore in CS, and I'm looking forward to building projects using various AWS services and just like experimenting with all these services.
Yeah, great. We have Matt up next.
Hi, I'm Matt. I've been here a while. I'm a grad student, and I like cybersecurity, so I'm interested in how these things integrate some security systems.
Yeah. Hi, I'm Ali. I'm PhD student last year. PhD student from environmental affairs, science department, and I started looking for a job and realized, oh, this is more about computer. If you don't know computer, no jobs. So one of those was like cloud computer.
So Great.
Yeah, clean up everything, big data.
No, that's great, and that's a very interesting background to come from. Yeah.
Yeah, I'm really like to learn more.
Wow, that's amazing. Yeah.
My name is Ine, and I'm a CS major, and I'm responsible for avant-garde groups.
Great, great. And yeah.
My name is Declan. I'm a freshman in computer science, and I don't know much about cloud computing, but I know it's a growing field, so I'd like to learn more about it.
Great. Yeah.
I'm Eric. I'm a sophomore in computer science. I'm just kind of learning more about cloud.
I'm Sanjeev. I'm a freshman in computer science as well. And I'm here because I've always heard about cloud computing and I just want to learn a bit more.
Great.
My name is Aki and I'm a business major. I'm a freshman and I'm interested in this because I want to learn something outside of business.
Well, great, amazing. So we.
Yeah, I gotta introduce myself.
Nice.
Hi, my name is Rahul. I'm a CS senior, I guess. I'm just here to learn.
Yeah. And former board member as well.
Oh yeah, former Euro.
Yeah, great. And let's see, before we close it.
Oh yeah, lead technical writer as well.
Yes, yeah. So anyone online would like to introduce themselves, and I believe you can see the slides online. I believe you can see the slides too. So if you, I can't see the list of people who are on the call right now, but if you want to speak up, go ahead and do that. I'll give you like 5 seconds. Okay, great.
I honestly don't mind going.
All right, go ahead. Go ahead.
I'm not sure how to talk about this because I'm technically an alum. My name is Anthony Chang. I'm an alumni. I graduated this year. So I'm not sure what I should say as my major. So my major was computer science. So I'm not sure I can go about SPP.
Yeah, yeah. Great. And what interests you about cloud computing? Turn it up.
Honestly,
let's see.
I feel like I met a couple people yesterday. During like Dylan from help that decided to start talking. I learn more about this.
Oh.
Because I kind of just realized graduating, finding a part-time job, kind of just like lost. I'm just lost.
Okay, well, hopefully this club will give you a direction to go in. Great. Anyone else online?
Hello, my name is Anthony. I'm a freshman. I'm making computer science. What interests me about cloud computing is I don't really know much about it, so I'm to learn more about it and see what I can learn.
Great, great. Next person online. We'll wait like 5 seconds, so like 5. It's muted. Well, good. Okay. Is someone about to speak?
No, I think we're good.
Okay, great. All right, so 5, 4, 3, 2, 1. Okay, great. So we got a range of responses, and I just want to say thank you all for coming. So we got freshmen, we got sophomores, we have juniors and seniors, even alums and graduates. We have a wide range of people, which is great. So it's great that you're all here, and a lot of you are very new to this. So let's go ahead and learn more about what cloud computing is. And now I'll invite Alvin up to take care of the rest of the slides.
Yeah, great. All right, what is cloud computing?
You want me to talk about effect? Sure. Sure. I'm happy to take over here. So what you see here is that cloud computing is, if you want, a set of technologies, right, that have become very popular, right? Very, very popular. I am old enough that I have lived through quite a few technology incarnations, right? And many of which came and then went away, you know, and I remember when, you know, the first virtual machines, you know, were introduced, everybody thought that's it. We're all gonna have, you know, hypervisor systems in our racks, and we're gonna have virtual machines from now. That everybody thought, boom, that's it, right? And then a few years later, that all actually, or I mean, it still exists, but you don't have your own virtual machines for the most part because of that. So it's fascinating, right? And it's still growing, right? You see that it's projected to grow to really high numbers. So over 70% of American companies plan to increase their cloud budgets in 2022. So I would argue that if you are not in the cloud today, or not already in the cloud today, or have no plans of being there very, very fast, you kind of like miss the boat, and you're missing big opportunities for your business as well, right? Because why are people doing it in the end, right? I mean, being cool is one thing, right? But at the end of the day, for many people, this is about business, this is about money, right? And this is about them, businesses, and also technology companies being able to do things that would be very, very difficult and expensive for them to do otherwise. But this is why cloud computing is so popular, right? So, and by the way, there's still a good number of companies who do a mix of things. There's certainly a number of companies who do only cloud computing. There's still some companies who have a mix of both cloud and also private and public cloud. So, huge amounts of data, right? I mean, zettabytes is even it's like one of those things that you hear once in a while, but you can't really visualize, right? I mean, we all kind of like maybe know what a terabyte is at this point in time, because many of us have that in our laptops. But the cloud is just essentially limitless, right? It's limitless in terms of how we think about how much data we can store there, right? Here it says human error is to blame for 88% of cloud breaches. Cloud security is a top concern for 70% of enterprises. So I would say that as far as I know, this is true. It's still human errors, but the wind has shifted in terms of security, because it turns out that cloud providers sort of kind of like force you to some extent to be more secure than if you just did everything by yourself, because you cannot really use many of these systems without them being patched. Obviously, the cloud infrastructure itself is being maintained. Even from your own perspective, if you do things yourself, for example, you can't really set up HTTP web servers anymore. You can't use weak ciphers. You can't use technologies that have been deemed unsafe or insecure. So in that sense, you get protected. Right? So in a way, I would say cloud computing today, and then this is a little bit of a subject to go on and on about, but I would suggest it has actually improved security. The battery is running low. Cloud can answer. Remote work has increased with the cloud computing. Yeah, it's also true because because of this way of us of essentially, it's so funny because when I started with computing, right, people actually were working on what was called terminals. Those were like basically screens and keyboards that were pretty dumb, and they had like a really basic connection to what was called a host computer, right? And then the PC was invented, and the PC became hugely popular, and of course still very popular today. But in a way, today we're almost returning back to this model where our PC system is basically kind of a terminal into the cloud, into cloud computing. So things kind of like reversing in a way. It's interesting to see that, right? And that's one interesting way to think about it, because at the time everybody thought host computers, they're gonna go away. Nobody needs those anymore. I want my laptop to carry on. Now we're going back to these cloud computing systems because we realize what I really want. I want to run my humongous AI models, and there is no laptop big enough for me to execute those, so I need some other way of doing it. So it's a reverse of it. All right, and then we go to the next slide, please. These are the definitions. So, what is cloud computing? So, what's funny about it is that it's not necessarily obvious to many people what it is. I also will say I have like a little bit developed a love-hate relationship with the name itself, because cloud computing is an ingenious name because it can really mean a lot of different things, right? It's also clouds. If you think about it, the first thing when you say clouds, people think about clouds in the sky, of course, right? And clouds, you can see them, but you can't touch them really, and you can never really get close to them. And when you think you get close to one, then it's gone, and then it's somewhere else. And it's a little bit sort of kind of like so. So it's not something that is easily hard to grasp. And this is true for cloud computing technology. So in a way, it captures that. But on the other hand, what is it? What really is it? And I like here so in the National Institute of Standards and Technology, I would say it is a model for enabling computing resources. That's what I would maybe like you to remember. So it's a pitch. It's a model for enabling. So what are other models? One model is that I can buy a computer and use it. Another model is I can rent it. Or another model is if you go to some place, the library and use it. So it's this different model that in cloud computing, more or less, so it's a model where I can start using these resources over the internet, and the only thing I need is some sort of access to the internet, which I usually get via my laptop or via some other. That's sort of kind of like one way to think. But of course, these computing resources, they are convenient, on demand, all these things that are listed here, right? And then there's a lot of associated benefits with that, right? So typically, one way of how people also talk about cloud computing is they say to qualify for cloud computing, it has to have certain characteristics, right? It has to be easy, it has to be fast, it has to be managed, it has to be on demand, all these things, right? That we expect to be. Right? And here, the more informal definition refers to the delivery of on-demand computing resources and services of the internet. Basically the same thing, just said in different words. We can say this in different words, right? But essentially, again, the way I want you to think about it is that it's a way of enabling computing resources, which both of these definitions say one way or another. And essentially, these computing resources, of course, are accessible and live from our perspective, in the internet. Right? So that's how we have to do it.
Can you expand on what you mean by computing resources?
Yeah, so it can be computing resources. It's a vague term, right? Absolutely.
Yeah.
It's a good question. Right? So it's a lot of different things, right? So, and this is kind of like what makes cloud computing a little bit hard to really put in a sort of in a box, so to speak. Because for some people it's hardware, right? For other people it's software. For other people it's development platforms. For other people it's storage and databases. For other people it's hosting kind of like capabilities for websites and other applications, right? And for Netflix, obviously, it's again something. It's a streaming platform, so to speak, right? Or that's what they turn it into, right? So it's everything that we think of when we say it has to do with computing. Computing has to do with a lot of different things, right? But the point is that it's so many different things that it says here, right? In networks, virtual machines, storage, applications, and services. But again, those are a lot of different things, right? There's a lot of different things. Here, of course, for a CS major, right? The cloud is so to speak a little bit of a playground where I can play writing applications and computing, right? And do bigger things that I could do on my own laptop, or sort of kind of like which is super cool for us because it's a super cool thing to play around with. Right? That's why we like it. And of course it becomes a super powerful development platform as well. Right? So because it's our choice of way of creating new solutions and computer programs today. So, yeah. All right. Next slide. All right. Where did the term cloud computing originate from? That's actually a great question because it's not super hard. It's not like some organization at some point came out with it. We have a few here. I think this is coming from the cloud computing wiki page, which I encourage you to check out as well if you're interested in. But it was used by even in 1996. Compaq was a computer manufacturer by HP. So they used it in an internal document for something they wanted to provide, right? For services they wanted to provide, right? And then there's another person here, so he's credited with using it. And then it was later popularized when Google and Amazon began building their cloud infrastructure. So, but again, I think the name is sort of like a little bit, yeah, you have to be a little bit careful with it, right? Because it's not, if, I like names that are pretty descriptive. Right? Alright, so somebody is unmuted. I mean, in some ways it's a very cool name. It's a good name. In other ways, I really don't like it, right? Because it's so kind of like you try to grasp it and then it escapes you. This is also what I mean. So, because today a lot of things get lumped into cloud computing, right? And some people think, well, that's cloud computing, and then, but they really only have a part of it, right? So it's a little bit limitless at the moment. So we'll see where it ends. That's what I'm interested in. Keep going. What are real world examples? So I'm gonna just stick to this list and then maybe add to it. Data backup and disaster recovery. So why is that? Why is this relevant? Why should I not back up to my own kind of like, I don't know, hard drive or own backup system? Well, the thing that the cloud gives you is the cloud. Cloud computing doesn't happen, right? Well, it's not something that happens in the cloud, obviously. It's something that happens in data centers that are spread all across the world, right? So there's various data centers in the US, in Europe, in Asia, and all across the globe. And not only are there's not one data center in the US, there's at least 4 large groups of data centers in the US. And when we talk about data backup and disaster recovery, what we mean is we have this ability of, when I store my data in the cloud, typically my cloud provider provides it will replicate the data to multiple data centers. So you have a lot of redundancy in your data backups, so you don't have to worry about it. And many of you may have heard the idea that if you back up your data, you want to have it in at least 2 or 3 different locations, right? Because if I back up my data on my hard drive into a separate folder, well, that's great if my folder gets deleted, but if my laptop gets stolen, then I'm done, right? So I better back it up to some other place, right? So now you back it up to the external hard drive. Now that's great. What happens if I don't know, the dog eats your hard drive? Not that will happen, to say. What happens if the hard drive is stopped? Now that is gone, right? So how do you do that, right? But if you store it in the cloud, you get many cloud providers provide tremendous amount of reliability. Like we specify this in number of nines. So for example, Amazon S3 provides 11 nines. It's almost impossible for you to self-replicate unless you build 100 data centers across the planet and pull everything away. It's impossible, right? And so there's a lot of benefit of doing that, right? On top of it being, right? So your laptop can be configured to back itself up to the cloud, and then no matter what happens, you will get it back. Basically, it's about as good as it gets. Right? So if you're not backing up your important data into the cloud, I highly encourage you to start considering doing that one way or another. There's options there. People work with Google Drive, people do other things, but I highly encourage you to start doing that. Website and application hosting. So the hosting piece is of course one thing. Now you don't have to build your own web server and have your own data center. But it's also, I think as mentioned earlier, one of the things that impressed me most about when I work with it a lot is this instant scalability. You can build a web server in the cloud and you say, okay, I have 10 users, or I have 10, also, oops, many more people should up. Now I have 100 users. Oops, all of a sudden I have 10 billion users, and it's literally a click of the button and your web application scales to these. Of course, it costs more now, but this is so easy, and these are things that I worked on personally. Scaling systems to larger levels used to be a huge effort. Right? And now it's just kind of like basically given to you in an instant, right? So that is really good. Big data analytics and machine learning. Well, this is all based on the fact that these systems, big data as it says, but also machine learning, AI model, they use vast amount of resources. You need, terabytes and terabytes of storage, fast storage. You need systems that have kind of like sometimes, hundreds of gigabytes and many GPUs. They're very, very expensive, right? So with the cloud, You can use them just on demand when you need it, and it's available. You can't carry around this big computer all day. You can power it. It's not feasible. And then it gets outdated. All these things. So it really enables a lot of these modern buzzwords, right? AI, big data, all these things, right? Basically enabled by software development and testing. Also true, right? It's very convenient. Setting up all these platforms is a lot of work, right? Virtual desktop infrastructure. Yeah, sure. So this is sort of kind of like, again, this idea that as long as I have a terminal, I can do in the cloud whatever I want. Right? It can be configured that way for whatever your person would be like. Content delivery network. So this has to do again with web technology. This is the fact that when we want to distribute data, right? For example, when you have your website, right? You want this website to be available across the planet. Now, what happens is that in modern setups is your data is static, and of course there's static and dynamic content. That's one thing. But this gets replicated, right? And if I go to Google here in the US, in the Boston area, I'll get my stuff from a probably fairly local Google server. And the same thing when I do it in Europe, it's not coming over here. It's going to go to the local because Google is replicating everything all the time. Right? These content delivery networks, they enable this sort of fact that your data, your web data, so to speak, that uses is everywhere and it's local in everywhere, right? With the things, processing and analysis. Well, again, this is a technology that. So for a while, people thought that pretty much anything that has a battery connected to the internet, right? But I'm not sure we're going quite that far. But there's a lot of sort of kind of like ideas about how can devices communicate, how can this be kind of like controlled, processed, and analyzed. Video, audio streaming, we talked about Netflix a couple of times, developed on solutions. So that is very, very popular for that. And again, don't think that when you all click on that latest newest Netflix release that you're all loading this from one location. Oh no, that's not how it is. We think that way because that's how it used to be. At least that's how it used to be for me. Maybe you don't think that way, but today when you load the latest Netflix show, it has already been replicated to hundreds of servers across the planet, and it will stream from the one that's closest to you and from the one that's fastest to you. It will self-adjust. And if it doesn't, then something went wrong. It's amazing how this works. It's amazing how this works. Email and productivity applications. Yeah, we all know Google Docs and Microsoft Office and other things. Those are becoming increasingly important now that the interface is finally sort of kind of like able to deliver these rich applications to us. I remember when I was young, we had these. We developed this thick client applications. The application like was had to run on the computer, and then they developed no, it just to run the browser, right? And then they put it on the browser, and then the browser version was so lousy and so bad because of all the limitations. Because there was no automated this that. So no, we gotta go put it back on the computer, then back on the computer, and then we had like Word and Office. And now finally we go back to the browser and the cloud. It's enabled by cloud computing, and it works decently well, right? Decently well. I'm still not sure where people who work with super heavy, rich kind of like graphics and maybe hundreds of pages documents feel like they want to do it all in the cloud. Like, still not sure about that. For the most part, for many use cases, it's plenty good. And CRM and resource management. I mean, these are just examples. There's so many different systems that live in the cloud, and again, the power of it is that they can be super distributed. It all sort of kind of like work at the same way. And I think this is certainly there's certainly many good ideas here. But what I would want to think about is that think of any big technology company. It doesn't matter if it's Amazon or Google or Facebook or Microsoft or any of those or any big technology company. But none of these folks would be as big as they are today would they not run basically on the cloud. They would they're not going to depend on the cloud. That's sort of kind of like imagine you have a taxi company, right? What's the two most important things in your taxi company as well? One is that we have cars, the other is that we have drivers, right? So the car for a taxi company, the cloud is basically the car for all these technology companies. It doesn't matter what we do. It's also true for finance companies. It's also true for many, many other things. So the cloud is this enabling technology that makes all these things possible. And that's really important to understand. So it's all of this and a lot more. All right, let's go to the next slide.
Alvin, just let us know what it is.
Want to take over or what are we doing?
Alright, for this discussion, career outlooks. Some career outlooks are a solutions architect, cloud engineer, a cloud administrator, and a security analyst. Alright, so cloud computing models. There's 3 models of cloud computing. There's public cloud, where you're basically hosting your infrastructure on someone else's computers. Private cloud is when you host your own infrastructure, and hybrid cloud is a mixture of both.
Just make sure that the people in the back can hear you as well.
Yeah, sure, sounds good. All right, so now we're going to talk about some cloud computing models. The first one we have infrastructure as a service. So basically what this means is you are paying a third party to use their machines.
You stop sharing real quick.
What's up, Howard?
Can you see it now?
Can't see it now.
Cool. So infrastructure as a service is a cloud computing model where a third party provider hosts and maintains the underlying infrastructure. So this would include your servers, storage, networking, and virtualization. So basically you're renting someone else's machine. So you use this to deploy your own apps, run your services, and all that sort of stuff. Next is platform as a service. So this is a cloud computing model where a third party provider offers a platform on which users can build, deploy, and manage their own applications. So these typically offer tools and services for application development, and they are very scalable, and they act as basically a middleware, database management, and other infrastructure components that you want, like some other things that probably go off on authentication, and other things like another example real quick, CDNs, stuff like that. Finally, we have software as a service, which is a cloud computing model where a third party provider hosts and delivers software applications over the internet. Users typically access the applications through a web browser or an API, and the provider manages all aspects of software, including maintenance, security, and upgrades. So here we'll give an example of these 3 different services where using pizza. So essentially, the way that it would be done before cloud computing was very mainstream was if you wanted to build a major application, you would have everything. So here, if you wanted to make pizza from nothing, you're starting just with a plot of land. You'd have to build a kitchen. You have to somehow figure out how to get gas. You'd have to build your own oven, probably find your own heat sources for that. You'd have to probably grow your own wheat to make some flour for pizza dough. You'd have to probably get some cows for some cheese, grow some tomato plants for tomatoes, and then you'd also have to cook all of that at the end.
I think you're going a little too far. I don't think people are making their own silicon chips.
But
I like it.
for infrastructure as a service, you're going to use that. This is probably what people would do if they want to just make their own homemade pizza from scratch. Is you already have a kitchen, gas, and oven in your house that you probably bought from like IKEA or something. So you would then buy some flour, make the dough, your toppings, and cook it. For platform as a service, it would also then provide you pizza dough. So you would just go to the store and buy pizza dough and use that to make your pizza. And for software as a service, this is probably the example we're most familiar with when you just go to something like Domino's, which is the pizza we have out there, where you just bought it from them and you can now use it. So,
Wait, do you guys want to relate it to actual computer terms?
hardware on demand. It is pay as you go, so you only pay for what you use. It's easy to manage since you're managing it through your code. You're not actually setting up the infrastructure yourself. Geographic flexibility, you can deploy it basically anywhere in the world. And some cons, since you're deploying your application on someone else's infrastructure, there's definitely some security concerns because they can basically do whatever they want. There's the dependency for availability, so you're kind of trusting that wherever you're renting the infrastructure, then they will actually be able to keep their services running. When you first migrate to the cloud, there's definitely some complexities in management. So you have to actually learn about the cloud services themselves and how they can connect with each other. And also, for customization, you're limited because you can only use the infrastructure provider. So some examples of infrastructure as a service. We have Amazon Web Services, which is what we will be primarily using this semester. There's also Microsoft Azure, Google Cloud Platform, IBM Cloud, and Oracle Cloud.
Right, let's talk about platform as a service. Platform. Well, platform as a service offers quick deployment. So I have a website, I have to make the code for it. I just write a few changes, push it to the cloud. There it is. There's your website. That's the cloud. That's the power of platform as a service. It's very scalable, as Professor Weiss mentioned earlier. So if you have 1 user, you have 10 users, say tomorrow you have 10 million users, your program won't break. It's part of the cloud. You can scale up and down the number of resources you have, and easily adapt to the needs of, say, your customers, and organization, and anything really. Easy collaboration. Just all the resources are shared by the power of the cloud. Everyone can work together very easily, collaboratively, have access to the similar code bases, have shared knowledge of how things are working, and it's very easy to manage. And reduce complexity. So in line with easy collaboration, since all the resources are shared, everyone has a general sense of how the cloud works. They can focus on what their product is. Say, I'm working on a website, I can focus on the front end design of the website, what I want it to look like, who my customer is, how I want it to work. I can get that to work very easily with the power of the cloud because it reduces the complexity of hosting the servers, hosting the chips, managing the software, all that sort of stuff. There are a few cons though. Because you're using someone else's infrastructure primarily, and you're using them as a platform, you do have some limitations on how they decide to implement some of the systems internally and how they interact with your product per se. So there are some limitations on how that would work. But generally speaking, most cloud providers have adapted really well. They know how most of their customers would actually want their system to work, the kinds of things that they're actually making. So that isn't too much of a con, but it's still something to consider. There is a big issue with vendor lock-in, which is common with, I don't know, if any of you guys use Apple products, you guys know exactly what I'm talking about. Green bubbles, blue bubbles, getting locked in with AirPods. Similar thing happens to the cloud with a lot of engineers and developers. You might get into the cloud with one service that you really like, that you want to say your website or your programs. Then you have to sign up for service B and service C. So that can end up happening where you end up getting too deep into an ecosystem provided by a particular vendor, which can be a financial burden. There's also potential security risks with infrastructures, but as Professor Weiss mentioned earlier, it's really not that big of a deal nowadays because, as I mentioned, almost 80% of actual cloud security concerns are actually sourced from human source errors and not actually because of the infrastructure itself. But it is still something to consider from an end-to-end perspective because you are giving your application to another provider to run on your behalf. And again, there's some customization limitations because of the way the infrastructure works. Some common examples of platform as a service. So there's Roku, there's Google App Engine, Microsoft Azure, which is the cloud platform of Microsoft, and AWS Elastic Beanstalk, which is a subsystem of really popular.
Oh, yeah, question got AWS Amplify.
Amplify, yes, Amplify is a really good one, which we use for our projects as well.
Alright, so software as a service, some pros
basis, like Dynamo TV, Amazon Aurora TV. So for cloud security, we have identity and access management solutions like AWS IAM, cloud networking. This is things like virtual private cloud, which is able to connect multiple cloud resources together in a secure environment. And finally, for processing large amounts of data with cloud analytics, so it's like AWS Redshift. Alright, now we're going to demo a Discord bot on AWS Link.
All right, we've all been waiting for it. Let's see the AWS cloud in action.
You guys all see this?
Yeah.
Alright, so for our CDK snap, we have a lambda function which will handle Discord bot commands and are responsible along with an API gateway. And once we hit CDK deploy, we get this URL.
You can write this in different languages if you have to. It's configurable. If you take pictures. Here, down.
Yeah, CJ and Alvin, I believe, just wrote this bot a few days ago.
So you did this yourself? Okay.
Yeah. Wow.
Yeah, I think that's worth mentioning. It's not something downloaded and just, it's very cool.
Can you show me the location where the demonstration is taking place?
Can you see the screen right now?
Oh, we might not be able to.
I think you should.
This is on,
Oh, it's still on the slide. It's on the
Is it-
slide. Sure, it's on the screen. Alright, can you see the screen now?
Yes, thank you.
Awesome. Alright, so it seems like actions else not working. So we'll just use the testing block. So once you deploy this, you can just so let's say you want to tell a joke. That developers are the game parsing HTML. Algorithm or word used by programmers when they don't want to explain how their code works.
But maybe just explain a little bit how it works for
Yeah,
folks here. because-
so essentially what we did was we used CDK to basically take what AWS resources we need and generate those on the fly with this code that we have written here. So all the Discord bot is really doing is when you make your request and send the message to the slash command, it's calling a joke API that we found online for free use, and it's grabbing one random joke from the programming tab and just sending it back to you. Basically, the bot's hosted on a Lambda function, so we're only getting paid for when it's being used. And so it's not being run on a server, or it is somewhere, but it's not being used until someone requests to.
Yeah, so this is the actual code for the bots. So you get the joke and just basically
Hey, it's Joe.
Awesome. So that's one thing you can do with the Discord bots. Why do Python programs with less? Can't see most.
I like that one.
Yeah, so another Discord bot that we actually made this summer is called Unibot, which can answer questions about school. So does anyone have a question they want to ask to the bot?
How much does it cost to live at University Students?
How much does it cost to live at this university? Or your team?
So you're feeding this to an LLM now? Or?
Yeah, so basically this bot will call LLM.
Well, like ChatGPT or what?
Yeah, GPT-4
Not sure about all the details. That'd be enough.
Okay, there we go.
There There you go.
regards to the web pages,
Yeah, I
Pretty good.
think that's the, is that the correct cost for it versus?
Great question.
They have elucidated that number,
Yeah.
but it gives you the
I
links where you
don't
can check.
think so.
Yeah, that's not the correct.
You think it's not correct?
That's
no,
unfortunate.
that, I don't think it's $5,000, I think it's like 2,000 something.
Okay.
So that's too high?
Does
That's
the
way too high.
does the link take you to the correct?
Nah, wait, hold on. No, I think it's getting it.
Is that really how much it is?
No, that's correct.
Oh, it's correct.
Let's Our meeting schedule will be every Thursday from 6:30 p.m. to 9:20 p.m. We have free pizza every meeting. Full details are in the QR code and make sure to bring your laptops.
Yes.
Wait, go on first.
Yeah, I mean,
More slide? Yeah, that's basically what I
Have you
said.
talked, can you,
Oh, the links after.
Oh, yeah.
can maybe one of you talk a little about what you're planning to
That's
do?
our
with
engage.
this?
Yes. Okay, great.
That's our Discord.
Okay, and right before you do that, if you could actually open up your web browser and go to our website real quick.
Yeah, absolutely.
Yeah, so actually we'll take 5 seconds for people to take a picture for that link.
Oh yeah, sure.
Just take a picture. Good to know that.
I think that's the link tree, right? So the button.
Yeah, link tree. Okay,
Yeah,
great.
you guys can just scan the middle one. That should have more.
Yeah, the middle one will take you everywhere else. All right.
Sweet.
Great. And so our, what we're going to be doing this semester is, yeah, I'll let you go up to the website, click on schedule. So UMLcloudcomputing.org. We got our website. There we go. All right. Thanks to Preet for working on the website over the summer. He did a great job. He did the heavy lifting. So we go to schedule. Our schedule for the semester is right here. We're still populating it, but if you scroll down on it, it gives you a little bit about what we're going to be doing each meeting. And this is not currently on the website, but for the next 3 weeks, we're going to be working on a hands-on activity, Photo Sky app. And Alvin, if you can actually go to click on the activities tab, click on Photo Sky, and actually click introduction. Yeah. And if you could scroll down and click on the link to the repo, demo, actually just open the demo. Yeah, there we go. All right, so what we're going to be doing for the next 3 weeks is learn how to build a cross-platform mobile app that will allow you to take pictures from your phone, upload them to the cloud, and read them back. And here you have a quick demo of all this work. So you see after you upload a picture and it shows up in AWS. This is just a preview of what we're going to be covering. So you could take this Android app, publish it to the App Store, and just make money off it, I guess. I don't know, integrate ads or whatever you want to do, but it's just one of those cool things that you can say, hey, I launched an app to the App Store. A few details about the app. It is cross-platform, so you could, while we have designed this tutorial to be for Android, you could follow the same process and convert it into an iOS app. If you have a Mac device, an Apple device, you can do that. And you can also turn it into a Windows DXE if you wanted as well. So there's a lot of flexibility. We're just going to be focusing on Android for now, but the pathway's there. So how do you get involved? How do you get started? Show up here next week. We may have a presentation right before, but right after the presentation is done, we're going to be doing this hands-on. And we have everything written down, all the instructions on our website, but here we'll hold your hand and walk you through it so that you know the AWS services you're using and the front-end application code, your design, etc. All right, and I think that's almost everything. Was there anything, did we want to do an attendance link at the end as well, or we could do that? All right, great. So what's the link to the attendance? Oh, it's on Discord. Okay. Not everyone may have Discord, but for those of you who do have Discord, please make your way to our Discord server. Please join that, because that is where all of our work takes place and all of the organization takes place in announcements, etc. And if you go to the bot channel, there's 2 bot channels. Wow. What happened there? There's only one. I think that might be a bug.
No, that was
Well, that one's fun.
That is fascinating. Okay. Oh, I don't think. see one. Just go to the one you can see. But yeah, so the link. Great. So CJ is just about to get the link. All right. So if you can, let's try this experiment. We're going to use the Discord bot that CJ designed. All right.
It might glitch out. We haven't tested it at scale yet. So.
Let's see how it works at scale. The power of the cloud.
What are they trying to do? Everybody's looking.
All right.
So do slash attend, type that code in, and then select which option.
CJ, sorry, Alvin, would you like to demonstrate for us? So type slash attend code 1814961.
For this one, you have the option to choosing
814
So go to bot and type that code in.
All right, nice. Great. So this was actually a Lambda function that CJ designed. So that's just a demonstration of all the cool things you can do. All right, and then as soon as everyone is done, just before we have the pizza, we would like to take a group photo to share on LinkedIn and Instagram, etc. If you do not want to be part of that photo, you can please just step out here outside the room. But in a moment, we'll have everyone stand up and walk to this side of the room. We'll do a nice.
So we just write 81419 here. What was the code? I think it was 81419. Like 119, I think so. So.
What was the code again?
Good. If you get applications
Yes, 149.
All right. Okay, if you're getting applications do not respond, it didn't go through, but it just got back. Yeah. You can try again.
It said I already used it.
Okay, sure. All right. Yes. All right. So if we can have everyone who wants to be in the picture, please come up here. Just stand over here. Call our people in the back. Call our people. We did a good guess there. Perfect. That was amazing. Yeah, we want to. All right. So everyone wants to be part of this picture. It's gonna be a tight one. It's gonna be good. It's gonna be good. All right. Yep. I did not.
That's a great turnout.
Yeah, that's a great turnout. Okay, yeah. All right.
Let me know what you want.
Not yet. No. We want to hear for the thing. Yeah. So yeah.
Just clump up. It's
yeah.
okay.
So okay. People in the front, you can like kneel down too. Yes, that works too. Yes. All right, let's actually have people kneel down in the front. Yeah.
Great job with the presentation. I'll kneel. Great job with the presentation.
Thank you. Oh, sorry. Which way do you want to speak? Okay, you gotta do it very good.
Was that?
I like the presentation, the slides you did.
All right. Ready, everyone? So make sure that you can.
No, I thought it was great.
Well, I have this too, so we can take a picture with this too. Yeah.
Does that get it?
Yes, it should get everyone. If we may have to move back a bit.
Can you move the cameras back?
Yeah, I know. So it's a wide angle, but let's see. So it covers everyone like this. So if we could all move back a bit, actually.
Do you want me to move somewhere else?
You can be in the picture too. So
it doesn't have to be one, but if we
yeah,
can-
it would be great if we could have you too. So maybe if you stand on to the side. Yes.
Is it easier for everyone to move back or for your phone to move back?
You know what? That's a great point. You can do that? Okay. You want to do that? Yeah. Let's see if I think.
Time photo with a stand so everyone can.
Yeah. Maybe we could do it with the stand that way. Everyone's in it.
You could be in the photo too.
Yeah.
42.
Wow. That is good. All right. I'll think I'll move it here because this PC is in the way. All right. Okay, so almost everyone is here. If we can try to move back just a little bit, if that okay. I know there's a lot of people, but it's, if we do this, it'll. All right, great. Okay, so I'm gonna get down here. All right, and so we're all gonna say cloud computing on 3. Ready? 3, 2, 1. Cloud computing. Wave to the camera. All right. Here we go. All right, there we go. We're all good. It's a video, so it takes pictures and a video. So yeah. All right, so we're good. All right, thank you everyone. Pizza is in the hallway.
Help yourself.
Yes.
And the small boxes are gluten-free.
Protocol for the pizza. Please take 1 slice first, just so that that everyone gets a chance. All right. Well, thank you for coming, Professor. What was